The moon is dying, and it is taking Earth's future with it. Not in any way the next 100 generations will live to see. But the process is already running. It has been measured with scientific precision for over 50 years. And the endpoint is a planet so different from the one that exists today that calling it Earth would be generous. This video covers what is actually happening to the moon, why it is leaving, and what Earth looks like when the process finally completes. Stay until the end, because the last thing the moon takes with it when it goes is the one thing that makes this planet livable. The moon is moving away from Earth at 3.8 centimeters per year. That number sounds laughable. It sounds like a rounding error on a cosmic scale, but it has been measured with extraordinary precision using laser reflectors left on the lunar surface by Apollo astronauts in 1969. Scientists on Earth fire laser pulses at those reflectors and time how long the light takes to return. The round trip, clocked in fractions of a second, has been getting longer every single year for over 5 decades. The data is clean, consistent, and unambiguous. The moon is not where it was. It is farther away than it was yesterday, farther than it was last year, and it will be farther still this time next year without a single exception in the record. Apply that number across geological time and the story changes entirely. When the clock back 1.4 billion years and the moon was orbiting roughly 40,000 kilometers closer to Earth than it is today. At that proximity, it would have dominated the sky. The tides it generated were not the gentle twice-daily rhythms that shape modern coastlines. Some models estimate ocean tides in that era reached hundreds of meters. Earth itself was spinning faster, producing days of only 18 hours. The moon was not just the light in the night sky. It was running the planet like a clock, and the clock is slowly winding down. Now here is the part that should genuinely unsettle anyone paying attention. The mechanism pushing the moon away is not some external force. It is not a collision or a gravitational intruder from deep space. Earth is doing it. The planet is pushing its own moon away, and it cannot stop, because the force driving the separation is the same force that fills every harbor and empties every beach on the planet twice a day. The moon's gravity pulls on Earth's oceans and creates tides, but Earth rotates faster than the moon orbits, which means the tidal bulge, the slight oceanic swelling toward the moon, runs ahead of the moon's position rather than sitting directly beneath it. That offset bulge has its own gravitational mass, and it pulls the moon forward in its orbit. Pulling the moon forward accelerates it into a higher orbit. A higher orbit is a more distant orbit. Every tide that has ever rolled in and rolled out has given the moon a push away from Earth. Billions of tides over billions of years, each one microscopic in effect, collectively moving the moon to where it sits tonight and then a little further by morning. The moon is not leaving because something went wrong. It is leaving because of the most ordinary process on the planet's surface. But the moon is not leaving quietly. Before it goes, it is taking something. Earth is losing its rotational energy to the same tidal friction that is accelerating the moon outward. The planet's spin is slowing down. Not in any way that a stopwatch could catch across a human lifetime. Earth loses approximately 1.4 milliseconds from the length of a day every century. That sounds negligible until the fossil record is brought in. Ancient coral fossils preserve daily and seasonal growth rings the way trees preserve annual rings. Those fossils, dating back 400 million years, show that Earth's year once contained more than 400 days. The planet was spinning faster. The days were shorter. The moon was closer. Every piece of that picture connects directly back to the same tidal mechanism that is still running today, still slowing the planet, still pushing the moon further out with every passing year. The planet is not what it was, and it will not stay what it is. So what does the endpoint actually look like, and is it as bad as the math suggests? The answer is yes. Possibly worse. Physicists who model tidal evolution project that eventually Earth's rotation will slow to the point where one side of the planet permanently faces the moon, mirroring the way the moon already keeps one face locked toward Earth. At that point, the tidal exchange stabilizes and the drift stops. The two bodies settle into a fixed mutual relationship across a distance far greater than the one that exists today. That stabilization sounds almost peaceful until the implications are laid out plainly. At that distance, total solar eclipses become impossible. The moon would be too small in the sky to cover the solar disk. The eclipses that occur today, where the moon fits over the sun with an almost suspicious precision, its apparent size matching the sun's disk almost exactly, are already a lucky accident of the moon's current distance. That window is closing. The eclipses will become partial, then annular, then gone. Future civilizations, if any exist to look up, will never see what humans alive today can still drive across a continent to witness. That loss is real and it is already in progress. But it is not the dangerous part. The dangerous part is this: Earth's axial tilt, the 23.5-degree lean that produces the seasons, that makes agriculture possible, that keeps climate zones stable enough for complex ecosystems to exist, is not self-sustaining. It is held in its current range by the moon's gravitational influence. Without a large moon providing that stabilizing force, Earth's tilt would wander chaotically over millions of years the way Mars's tilt does. Mars has no substantial moon. Its axial tilt has swung by tens of degrees over geological time, producing climate shifts so severe and unpredictable that any life complex enough to notice would have found itself on an increasingly hostile and erratic planet. Earth's stability is borrowed. The moon is the collateral. As the moon drifts further and its gravitational leverage weakens, the stabilizing effect on Earth's axial tilt diminishes. The rate of change is far too slow to register within any time frame a civilization would recognize. But the direction is fixed and the mechanism does not reverse. The moon's grip on the planet's tilt is loosening. The seasons that made this planet habitable are underwritten by a body that is slowly moving beyond the range where it can continue to guarantee them. Every year the laser fires from observatories on Earth. Every year the light travels out to the reflectors sitting in the lunar dust placed there by astronauts, some now dead, in missions that ended before most people alive today were born. Every year, the return trip takes fractionally longer than the year before. The measurement has never come back flat. It has never shown the drift pausing or reversing. It shows the same result with the same relentless consistency, 3.8 centimeters, every year, in the same direction. The moon formed 4.5 billion years ago from the debris of a catastrophic collision between Earth and a Mars-sized body called Baea. In the immediate aftermath, the moon was perhaps 15 times closer than it is today. The tides it generated would have been almost incomprehensible in scale. The young Earth, battered and spinning fast, was already beginning the long process of transferring its energy outward to the moon. That process has not stopped. For a single day, in 4.5 billion years, the moon has been leaving since the moment it was born. Humans have only known about it for 50 years. The Apollo reflectors made the measurement possible. Before 1969, the drift was theoretical. After 1969, it became one of the most precisely confirmed phenomena in planetary science. There is something worth sitting with in that fact. The same missions that are remembered for planting flags and collecting rocks also quietly installed the instruments that would one day tell humanity, in exact centimeters, how fast it is losing the thing that keeps this world stable. The moon will not be gone in any human time frame. It will be overhead tonight, and it will be overhead for billions of nights to come. But it will be slightly further away each time. The tides will be slightly weaker, the days will be slightly longer, the axial tilt will be held slightly less firmly in place. The change is too slow to feel. That does not make it less real. The laser measures it every year, and the number does not lie. 3.8 centimeters. Every year, without exception. If this changed how you look at the moon tonight, hit like and subscribe. Share it with someone who has never thought about what the sky is slowly losing. More coming soon.